and models. So if you remember that polynomial functions of degree 2 are quadratic, the simplest one is y equals x squared, which we learned about in chapter 2. It has a vertex at 0, 0, and then its pattern is to go over 1 and up 1, over 2 and up 4, and then we could go over 3, up 9, and it follows that growing pattern. The domain for a parabola is negative infinity to infinity, and the range is 0 to infinity with a closed bracket at 0. Now, the domain will always be negative infinity to infinity, but the range may change if we have a vertical shift up or down. So just going to watch those. Remember that these graphs, the original graph starts out decreasing from negative infinity to 0, and then from 0 to infinity, it is increasing. Parabolas are symmetric across a vertical line that goes through the vertex. This is called the axis of symmetry. The axis of symmetry is the vertical line that goes through the vertex. So here we have a parabola that opens down. The axis of symmetry goes through the vertex. Here we have a parabola that opens up, and its axis of symmetry also goes through the vertex. Since it is a vertical line, remember that vertical lines have equations that are x equals a number. So it's going to be x equals whatever the number is, that is the x coordinate of the vertex. In section 2.6, we studied graphing techniques for parabolas, and in fact, all parent functions. If you recall, that if there is a number out front that is vertical stretch or compression, it also tells you if your parabola opens up or down, because if that number is negative, that would reflect across the x-axis, which means the parabola would open down. So it is going to open up if that number is greater than 0. It's going to open down if that number is less than 0. We have a vertical stretch if that number is bigger than 1, and a vertical compression if that number is between 0 and 1. So that would be the number that is out front. And then inside the parentheses there, we have the horizontal shift, left and right. So that's the one that goes like backwards of what we think. So it is going to be a horizontal shift if we have subtraction. Oh, I don't like the way this is phrased. I'm going to make this right h units if, change that to subtracted. And left h units if added. Okay, I like that better. Then we have vertical shifts that are added at the end. And we have a vertical shift up if that is added, and down if it is subtracted. So I'm going to change those as well. So up k units if added, down k units if subtracted. So those are the same transformations that we saw in chapter 2. So nothing new there. Let's practice doing some of these graphs, because then we're also going to tell things like where is the graph increasing and decreasing, and we're going to find the x and y intercepts. So we'll have to do a little bit of figuring out how to do that. So give the vertex. The vertex is going to be found by figuring out where the start point is. So we're going to need to use the left and right up and down shifts. So use shifts. And that's when our equation is in what we call vertex form. These are in what we call vertex form, which was right here. Let's go ahead and label this vertex form, because we'll have another form later. That's vertex form. So let's talk about the shifts. This is a shift left 1 and this is a shift down 3. So the vertex is going to be at normally 0, 0, but left 1 goes to -1, down 3 goes to -3. So our vertex is at -1, -3. That's A. I'm going to go ahead and put that on the graph. -1, -3. Okay. Now that also tells me where the axis of symmetry is, because remember that the axis of symmetry, I'm just going to write AOS for axis of symmetry, is a vertical line that goes through the x coordinate of the vertex. So the axis of symmetry is going to be x equals the x coordinate of the vertex, -1. So we can graph that on our graph. It would just be a dashed line. It's technically not a part of the graph. It's like an imaginary line, but sometimes in my math lab will ask you to graph it. And I will a lot of times ask you what it is, but not necessarily to put it on a graph. So there we have B. Okay, C, the domain and range. I'm going to come back to those. And I don't really like how my math lab asks you to do domain and range, because they ask you for domain and range before they ask you to do the graph. And to me, that's just backwards. So we'll come back to those. And then where is the graph increasing and decreasing? Oh, we need the graph for that as well. So, okay, we'll come back to where is it increasing and decreasing after we have the graph. And let's find the x and y intercepts. So we can do that. We can do that with algebra. So to find the x and y intercepts, we need a little bit of notes on that. To find an x-intercept, we have talked about this before, but it's worth writing down again. You're going to sub in 0 for y, and then solve. To find a y-intercept, we're going to sub in 0 for x and also solve. So to find the x and y intercepts, I'll leave a space for E, and we'll say increasing, decreasing, and then F. Okay. So for our x-intercept, we're going to replace the y with 0. The y is the f of x part. So I'm going to put 0 equals 1/2 times x plus 1 squared minus 3. And I'm going to need to solve for x. I'm going to do this when it's in vertex form. I'll do this by the square root method. So I'm going to isolate the squared thing first. So I'll add 3 to both sides. And then I need to multiply by 2 so that I don't have that 1/2. So now I have 6 equals x plus 1 squared. Next thing I'm going to do is take the square root of both sides. Square root, square root. Remember that that gives me plus or minus the square root of 6. And then on the right side, x plus 1. And then subtract 1 from both sides. So I get x equals -1 plus or minus the square root of 6. This is actually 2 x-intercepts. One of them is at -1 plus the square root of 6, 0. And the other is at -1 minus the square root of 6, 0. In order for me to graph those, I will get decimal approximations. So I got -1 plus the square root of 6 is about 1.45. So I'll put that on my graph at about 1.4. And then -1 minus the square root of 6 is -3.4. So I'll put that on my graph as well. And then for the y-intercept, I'm going to put 0 in for x. So f of 0 would be 1/2 times 0 plus 1 squared minus 3. What's in the parentheses first gives me 1 squared minus 3. Then do exponents, then multiply, then subtract. So that is 1/2 minus 3 is negative 2.5 or negative 5 over 2. So that y-intercept would be 0, negative 5 halves. And I'm going to put that on my graph at negative 2.5 right there. Now to get the graph, I can use the growing pattern. So once I have the vertex, I could have graphed this without finding anything else by using the pattern. The pattern goes over 1, up 1, over 2, up 4. And then also left 1, up 1, left 2, up 4. But I have a compression out front, so I would need to multiply all of my ups by 1/2. So my new pattern would go over 1, up 1/2, over 2, up 2, and on the left as well. Over 1, up 1/2, over 2, up 2. So I'll use that pattern on here from the vertex. Over 1, up 1/2, and look at that, it landed right on our y-intercept. Then go back to the start, over 2, up 2 to right there. And then back to the vertex, over 1, up 1/2. Back to the vertex, over 2, up 2. And then I'm going to graph a parabola. That looks like this. So now I can use that parabola to answer my domain and range. Domain, well, we've already know every parabola has a domain of negative infinity to infinity. And the range, going bottom to top, the lowest y value is here at negative 3, and it goes to infinity. So the range is negative 3 to infinity. And then where's this graph increasing and decreasing? As I go left to right, my graph is decreasing first. So it's decreasing from negative infinity until I get to right here, which is at x equals negative 1. So it's decreasing from negative infinity to negative 1. At negative 1, it's turning around, and then it starts increasing again from negative 1 to infinity. So we always use open parentheses to show where it's turning around. So increasing negative 1 to infinity, decreasing negative infinity to negative 1. All right, let's see if we can get this one done right quick. So first part, find the vertex using shifts. So this one shifts right 2 and up 1. So the vertex, instead of being at 0, 0, will be at 2, 1. That also tells me the axis of symmetry, which is at x equals the x coordinate of the vertex, so x equals 2. Go ahead and put those two things on my graph. Vertex at 2, 1. Axis of symmetry going through there, which means I can fold my graph in half across that axis. Okay. Next part, I'll come back to range, but I already know domain is negative infinity to infinity. I'll come back to range later. Next, increasing and decreasing, which I will come back to as well after I have my graph done. Oopsie. So when you're working on your My Math Labs, you should be graphing these on paper anyway. So go ahead and work all the way through your problem and then answer your domain and range questions and then fill out the rest of it on My Math Lab. But yeah. Then x and y intercepts. So x intercepts, we replace the g of x with 0. So 0 equals negative 3 times x minus 2 squared plus 1. And then we need to solve for x, so I will subtract 1 from both sides. So negative 1 equals negative 3 times x minus 2 squared. Divide both sides by negative 3. Leaves me 1/3 equals x minus 2 squared. Take the square root of both sides. I get plus or minus the square root of 1 over the square root of 3 equals x minus 2. And then I'm going to add 2 to both sides. I'm going to work to over here. So I get x equals 2 plus or minus, the square root of 1 is regular 1, over the square root of 3. Well, my math lab isn't going to like that. You have to rationalize that denominator. So I need to multiply by square root of 3 over square root of 3. So I get x equals 2 plus or minus the square root of 3 over 3. So my x-intercepts will be at 2 plus square root of 3 over 3, 0, and 2 minus square root of 3 over 3, 0. So let's put those on our graph. 2 plus square root of 3 over 3 is 2.6. And then 2 minus square root of 3 over 3 is 1.4. Ooh, those are really close. The y-intercept, we're going to plug in 0 for x. So I need g of 0 equals negative 3 times 0 minus 2 squared plus 1. Do what's in parentheses. So negative 3 times negative 2 squared plus 1. Do the exponent. So negative 3 times 4 plus 1. Multiply. So negative 12 plus 1. Then add to get negative 11. So my y-intercept is at 0, negative 11. That's going to be down here. I'll just estimate it to be about right there. Now let's go back up and use the pattern to fill in the rest of our parabola. I have a vertical stretch of 3 and a reflection across the x-axis. So this means the parabola opens down. And this means I have a vertical stretch of 3. So in my pattern, I'm going to go over 1, but I'm going to go down. And instead of 1, I have to stretch that and go by 3. And then I'm going to go over 2 and down. Instead of 4, I would have to stretch that and go 12. And then left 1, same pattern, down 3, left 2, same pattern, down 12. So starting from the vertex, over 1, down 3, left 1, also down 3, back to the vertex, over 2, down 12, back to the vertex, left 2, down 12, which puts me right at my y-intercept. So it looks like everything lined up correctly for me to draw my parabola. And now I can get the range pretty easily, bottom to top. The lowest y value is negative infinity, and the highest y value is right here at 1. So the range will be negative infinity to 1 with a bracket. And then increasing and decreasing. This parabola, if you start at the left arrow, it's increasing first. So it's increasing from negative infinity until the x value where it turns around, which is at 2. So we are increasing negative infinity to 2, and then we are decreasing from 2 to infinity.